Hello everyone. In this lecture, we will discuss Kruskal's algorithm. Kruskal's algorithm is used to find a minimal spanning tree in a weighted graph G. You know a weighted graph? A graph is said to be weighted graph if each edge is assigned a real number, that is weight of the edge. The steps of the algorithm are as follows. The first, what we have to do, you have to arrange all the edges of the graph in increasing order of their weights. It means if you arrange the edges in increasing order of their weights, it means the first edge will have the minimum weight. So the next step, you have to choose the first edge, that is the edge with minimum weight, and mark the corresponding vertices as the traversed vertices. Third step, choose the next edge. If it does not form a circuit, it means you have to select the edge with the second minimum weight and you have to check whether this edge forms a circuit with previously selected edges or not. If it forms a circuit, it means you have to exclude this edge. But if it does not form a circuit, then you have to select it. And you have to mark the corresponding vertices as the traversed vertices. Step number 4, you have to repeat step 3 until all the vertices are traversed. So in this way, you will get a spanning tree which will be a minimal spanning tree. Now we go for one example. Here this graph is GV and we have to find a minimal spanning tree in this graph using Kruskal's algorithm. So first thing which we have to do, we have to arrange all these edges in increasing order of their weight. So we'll start with the minimum weight 2, edge is B. So the first one is B, the weight is 2. Second one is AB, the weight is 3. Look at this, the weight is 3. Third one is BC, the weight is 5. The third one, this one. And next 6 weight, CE, C6. Next one AE weight is 7. The next one is ED weight is 9, then 10, then 12. So look at the ED, CD and BD. So in this way I have arranged all these edges in increasing order of their weights. Now I write the set of vertices of this graph. V is A, B, C, D and E. So this is the set of vertices. Now I have to select the edges one by one. So I start with the first edge, that is BE. So select this as B. So B, now this edge is selected BE and the weight of this edge is 2. The corresponding vertices are B and E. So mark these two vertices B and E as the traversed vertices. Now next edge is AB. If you check AB, if I add AB, so no circuit will be formed. It means I can add this as AB. So this is weight is 3. Now AB, the corresponding vertices are A and B. B is already marked, so I have to mark A. So 3 vertices are marked. It means we have traversed 3 vertices A, B and A. And this edge is also selected. Now BC, look at this BC. If I select BC, again no circuit will be formed. It means I can select this as BC. The weight of this edge is 5. So this edge is also selected. The corresponding vertices are B and C. B is already marked. Now I have to mark C. Now only one vertex D is left. So now I have to check the next edge. Next edge is CE. Look at this CE. C. If I include CE, a circuit will be formed. It means I cannot add CE. So I will exclude this edge. The next edge is AE. AE. Look at this. If I include this edge, again a circuit will be formed. It means I have to exclude this edge also. The next edge is ED. ED. So if you include ED, no circuit will be formed. It means you can add this as ED. The weight of this edge is 9. So the corresponding vertices are E and D is already marked. Now you have to mark D. All the vertices are marked. It means your process is terminated. You don't need to go for all these selection of all these edges. The process is terminated because all these vertices are traversed. So this is the minimal spanning tree and the weight of this minimal spanning tree is 2 plus 3 plus 5 plus 9, and this equal to 5 plus 5 10 plus 9 19. So this is the minimal spanning tree, and the weight of this spanning tree is 19. So in this way you can find a minimal spanning tree in a given graph using Kruskal's algorithm. So I hope that you got the concept of Kruskal's algorithm, and you can apply this algorithm for any given graph to find a minimal spanning tree.